Hi, everyone. Thank you for remaining that late. So I'm going to talk today about something which is actually quite similar to what was discussed here in the just recent presentation, but with some twist. So I'm going to talk about task of text similarity to find similar items on eBay based on item titles. Let's see, there's also, there's no, that's not working. Anyway, so just a few words about eBay research in Israel. So we have 3 groups today. One that I'm part of is the selling group that try to help sellers, giving them tools to better optimize their listings on eBay and sell more eventually. We have the structured data research group working on improving the catalog of eBay. And a new group recently started for buyer experience, helping improving the experience buying at eBay. Okay, so I'm gonna start with a short introduction about sponsored items on eBay and just giving a taste of the specific business use case, although what I'm gonna talk is actually more general for this, from this specific use case that started this project. So as similar in many e-commerce websites and also in Google, today you have the ability as a seller to, and it was actually launched about a year ago, to pay eBay a bit more, so you will get a boost in the ranking of your item during search. Okay, so this is an example, and you have this, if I do that, you can see that. Yeah, so you have this sponsor tag, okay? And the idea is that when, as a seller, you come to eBay, you want to sell something, in some point, eBay tell you sell it faster, boost your item visibility with this premium placement on eBay, and pay only if your item sells, okay? And now if you're a seller, you need to decide how much you're willing to pay to eBay that your item will be promoted. And there are basically 2 main things that you need to consider. One is how much you're just willing to spend on that, and basically you decide about the percentage of the sale that you're gonna pay to eBay. And the second thing is how do you want to compete with others, right? So you know that if you're gonna pay more than your competitors on the search results, you're probably gonna be ranking higher and vice versa, okay? And us as a research in the selling team, we wanted to help sellers to have a more educated decision about what is the trending rate that their competitors are currently using, okay? So when you see this number here below, oops, sorry, this trending rate, this is the number we wish to help sellers to give them this insight about the similar items and which ad rate they are using, so they'll have a better decision. So in high level, just to summarize what I just said so far, when there is a seller listing a new item, we wish to find the most similar item to this item, so we can learn what are the ad rate matrices of those similar items, and then provide ad rate guidance to the seller about his direct competitors on the search results. Okay, so how we can find the most similar items or his competitors? And this is basically similar to a very known problem in NLP for text similarity. And I didn't mention it, but the data we have in this point of the selling flow is basically almost only the title of the item. And there are different reasons for that. One of that is that, as you might know, sellers on eBay have relatively high freedom in which data they provide to eBay. And many times we don't have a lot of structured data on the items. We don't know what is the serial number or the brand and stuff like that. But we do have the title, which usually include the essence of the items sellers are trying to sell. So now when we have the title, we wish to find the most similar titles on eBay catalog and see their ad rates. And again, there's many different types of text similarity approaches, while the simplest one are edit distance or Jacquard similarity, TF-IDF. The more advanced ones, including the word embedding, like word2vec and fasttext, and the most recent approaches, including a sentence embedding directly, like BERT and send2vec. We did, by the way, tried BERT in this scenario. We even fine-tuned BERT with task specific of annotated similar items, but actually could not get any significant improvement comparing to just Word2Vec or FastText. And eventually we started with this more basic approach of using Word2Vec as our word embedding approach. So Word2Vec, as the name says, right, is creating embeddings or vectors per token in the title and do not give you embedding. And again, embedding is just a vector representation of text. So Word2Vec give you this vector representation for each token in the title and do not provide you the entire sentence vector representation, which we wish to have in order to find similar vectors in this high-dimensional space, and by that, finding those similar titles. So there's different methods how you combine those word vectors to a single sentence vector, while the simplest one is just taking the simple average of the 4 vectors, and more advanced ones, not that advanced as well, actually, is TF-IDF or smooth inverse frequency. So we started with a simple approach of just simple average, which actually known to be working in many use cases relatively just fine. And indeed, when we use this method, you can see in this example of a test title we use and finding the most similar titles based on Word2Vec representations with average, simple average. We see just a single example, the things looks relatively fine. We have the same item more or less. And that's true in many of the cases. But when we started to look a bit in more details on our results, we started to see that there are some cases which the titles are similar, the items are similar, but actually different in some of the most important aspects of those items. So in this example, we have this test title of a Fallout 4 video game from Xbox One, and Word2Vec find the most similar items to be indeed Fallout 4, however, from different console, PlayStation 4. The second most similar item was Hitman, which is a completely different video game from Xbox One. So it's easy for us as humans to say that although the vectors are very similar, the essence of those items are quite different, okay? Another interesting thing to see here is that all those titles have this brand new factory sealed, at the suffix of the title, okay? So we all already starting to understand that Word2Vec, when you use simple average, probably give more weights, or let's say the same weight to those brand new factory sealed part of the title, which sellers are using many times as marketing phrases, and find similar items that has this brand new factory sealed, which is obviously less important in our case. This is just another example. It's an NFL sticker. Again, we find similar stickers from NFL teams. However, the essence, which is the NFL team, is completely different, okay? And if you think from a buyer perspective, users usually don't want to buy a general NFL sticker, but they usually are fans of a specific NFL team and they wish to buy a sticker of their NFL team they like. Again, we see this suffix of choose size that again tell us that probably that can affect the similarity we see. Another approach to overcome this issue is using, instead of a simple average, use the TF-IDF weighted average. And TF-IDF in our context can be thought as just how popular the token is in the entire corpus. Okay? And the idea is very simple in TF-IDF. If a token is appearing millions of times in your corpus, it's probably less important than the more rare tokens in the title. However, in eBay, titles at least, when you start to look on this idea, you see that it's not really working. So in this example, when I look on the frequency or how much abundant the token Fallout in the catalog, you see that it's relatively rare. There are 70,000 results, 70,000. However, for the Xbox One, Xbox One is extremely important, we see that one appears, not surprisingly, tons of times on the eBay catalog, even more than the factory token, which is less important in our case. So again, just giving low weight to tokens which appear a lot of eBay catalog or specific vertical do not really give you the importance of each token in our cases. And by the way, it also has to do with the popularity of items being sold on eBay. So for example, tons of people sell smartphone cases on eBay, So if you search for case, you'll see very low number of, extremely high number of results, but it doesn't make the token case not important in the title of an iPhone case or a Galaxy case. Okay? The case it is the essence of the item comparing to brand new or free shipping. Okay? So a different approach we were thinking about is train a model that will tell us what is important, what is not important in each title. And then using this model weights to creating this average or smarter average that give more weight to the more important tokens in the titles. And ideally for training such a model, we need labels. And such labels could have looked something like that. If you have a Fallout 4 game, we wish to have those label as a Fallout 4 Xbox One, and someone would tell us that this is the important, and if we have tons of pair titles and labels like that, we can train a supervised model and solve this problem in theory. However, getting those labels is, of course, not trivial. You do have the possibility to manually tag titles by human agents. However, that's take time, it's costly, it's not very scalable. And also, you have a big problem of domain expertise. So if you want to find human agents that will give you these labels, so for many domains, it might be easy, like for if it's an iPhone, everyone knows what's an iPhone. But in eBay, you sell tons of really rare, unique stuff that I have no clue what is important there and what is not. And so if we just take random human agents to help us with that, he will not know what is important in many of the huge variety of items exist on eBay. So that's a big problem. And then we thought about a different solution, which is using the vast data we got on eBay from the user's search queries. So the assumption was that when users are searching for an item on eBay, they usually do not search for a brand new factory sealed, but they will search for Fallout 4 Xbox One. And the assumption is that when the user search something, they are looking for the essence of what they are thinking about of the product they are looking for. And indeed, if you look at just from terms of the size of the titles versus the queries, so the median size of queries on eBay will be about 3, and the median size of titles is 12. So we have this, possibly it makes sense that those 3 tokens might be usually the essence of those titles. And when you think about the user journey, you start with searching in the search box, and then eventually he might or might not click on specific item title. So we decide to take those clicks by the user and say that we can use them as labels. So we just take the title the user clicked on together with the search query, and now we have label for each title that was at least clicked on eBay, which means billions of training data, actually. So when we have such all this large number of labels, we decided to use starting with like 10 million pairs of titles and queries, selecting again only clicked titles, meaning the titles are really the thing the user had in mind when he was using this search query, and the results were okay. And we're training a model, we called it a listing to query model, okay? Moving from a listing to a query. In the bottom, we can see this diagram summarizes what I just said. So the user starting with a search query, you see the search page results, is clicking on an item, and then we take the item title and pair it with the query. We also have the possibility to select only purchased items. We also tried that. We didn't see any significant difference between the two options. Okay, so now we have those tons of label data. How we train a model. So one possibility is to create a generative model. You can take the titles, the queries, and create this translation-like model that translate each title to a query. And we did that as well. But another approach we did for the similarity task is using a sequence tagging approach, which is similar to like named entity recognition, which in entity recognition you tag each token as an entity, for example, organization or a person or location. In our case, in the bottom sentence, we just tag each token if it's a keyword or not, based on the query. If the query was Fallout 4, we tag those tokens as a query, and the other ones as a not query tokens. So it's more simple than the name data recognition, since we just have two classes, okay, not more than that. Keywords are not a keyword. We played with different modeling approaches. Again, we tried to use BERT for that, and that was not a very successful attempt, I must say. And it might have to do also with the unique jargon of eBay titles, and also the fact that it's very short text. BERT is pre-trained on much larger corpus than just 12 tokens. And then we found this really great package that's called Flare by Zalando Research that is really focusing on sequence tagging task, and they got back then at least state-of-the-art results for NER and part of speech tagging. And the idea of Flare is nice, is very cool from the fact that you can combine multiple different pre-trained embeddings as input to your model. And in this case, we use combination of both word embedding from Glove and Flare character-based embeddings. You concatenate those two kind of embeddings together, put them into a bidirectional LSTM model, together with a conditional random field that also learns the transitions of a query to a non-query token. And we trained this model. I'm not showing it here, but we did multiple evaluations, and we're very happy with the results we saw. And then we went back to the original goal we had, which was how we can create a more or smarter weights or a weighted average to generate a vectorial representation of the sentence. Okay, so in this case, we can see in the new Apple Watch 4, we got the word-to-vec vectors, and it can be any model vectors, can be BERT or fasttext. But then for creating a weighted average, we use the listing to query model that give you to each token what is the probability that this token will appear as a search query, which we interpret, or you can see that as the importance of this token from a buyer perspective. And as you would expect that new will get a lower score comparing to Apple Watch, as you see here. So the final representation of this Apple Watch will have much less influence from the token new. Okay? And indeed, when we use this combination of word-to-vec and listing to query, so you can see that in the third example in the similar titles, we now were able to find what we're expecting to see a Fallout 4 game from the same console, Microsoft Xbox One. And the interesting thing, And the interesting thing that we no longer see this brand new factory sealed as a suffix of the sentence, okay? Because listening to query, the model gave it low scores, so now we have this DLC included, which is just an extra package, come with this video game, and we were able to find more similar items. We obviously did several evaluations for these approaches. It's always hard to do evaluation for a similarity task. We did several of them, like what is the percentage of similar items from the same brand or from the same category. And we also did a more manual evaluation. We used, again, human agents, gave them examples of similar items from the different models, asked them to rank how similar each title is between 1 and 4. And we indeed saw that the smart average together with the listing to query weights gave 20% more perfect fits than the regular word-to-vec, and also reduced the bad fits by 30%. Okay, so one of the coolest things about this project, at least from my perspective, was that at the end we realized that this actually approach can be used in many different domains on eBay, in which one of the most obvious one is query relaxation. So today, if you search on eBay for a specific title, not for a query of 3 tokens, but rather, let's say you copy-paste the title from Amazon, you better not do that, but you copy-paste the title from eBay and try to see the results, there is a problem and you usually see this no exact match found. And there is simple algorithms on eBay and other e-commerce websites as well that just try to find some of the tokens in the titles. And then you can see that what can happen is that this kind of algorithms might tell you that this is the most similar or the result you will get on eBay, which is a completely different video game. It is Fallout, but it's a completely different video game. And we have tons of Fallout 4 video games from Xbox One on the site. And again, because it's just trying to randomly find similar tokens, and again, we have this new factory sealed in the suffix. So the idea is that when you have this model, you can just relax the query by removing or giving lower weights to the least important tokens, and then run the search on our search engine, and hopefully get better results. And now we are in the final steps of the search team in eBay, on the final stage of evaluation, if that's indeed the case, as we think. We're also now using it for other guidance for sellers. So we are helping sellers, for example, to set the prices. So again, to set the price, we want to find the most similar items, what the prices they are suggesting. You can also use it for keywords recommendation for titles, if you want to optimize your title. So you can think that you can find similar titles to a seller title, find which tokens they are using that users are searching for, that the seller is missing, and suggest him to add those keywords to this title because users are searching for that. And last, you can also use that for search term discovery, and also use it for example, help sellers to bid on specific tokens. If they want to promote items and bid on specific tokens, now they can know which tokens they should, or more likely to bid on, because those are the tokens that will lead to their item specifically in search. Okay, just last sentence. We are, as I said in the beginning, we have a new group from Buyer Experience that we are now hiring an intern, or also a summer student, and also full-time researcher. So if you are interested, please send me an email, or just go to eBay career website, and you'll see that. That's it. Be happy to get questions.